All right, this lesson is about similar triangles. Now remember, we already know that similar triangles means we have two triangles in which all the corresponding angles are equal. Again, if the triangles are similar, the corresponding angles are equal and the corresponding sides are proportional. Now, what if we're asked to prove whether or not two triangles were similar? Well, we have three shortcuts for how we can do that. The first one is called the angle-angle similarity postulate. And what the angle says is if you can verify that one angle of a triangle is congruent to the corresponding angle of another triangle, and you have a second pair of corresponding congruent angles, then we can conclude that the two triangles are similar, which then means we can start to investigate things about the proportionality of their sides. The second one is called the side-angle-side theorem. Side-angle-side similarity theorem. This one starts off by saying if you have a pair of angles that are congruent and you know that it has a pair of corresponding sides and a second pair of corresponding sides that we are able to determine are proportional. Now remember how you check proportions. You either simplify the fractions and they're equal, or you cross multiply, use the cross product property. But if we're able to determine this, we have what is called side-angle-side similarity occurring. The third scenario involves all three sides, so you know nothing about the angles. In order for side-side-side similarity to kick in, we have to know that all three pairs of corresponding sides must be proportional to one another. If we have three proportions of sides that exist, all right, and that are true, then we can say that the triangles are similar. Remember, what again it means for proportionality to occur is we have ratios that can be simplified and they are all equal. And if that doesn't make sense, remember we can always use the cross product property, also known as cross multiplication. All right, so let's take a look here. In this first problem, they want us to determine if the triangles are similar. All right, I look at the picture. They give me no measurements of sides. They give me no indication of angle measures. But I do know from the past that this angle, T, must be congruent to this angle, H. Why? Two parallel lines cut by a transversal, alternate interior angles are congruent. Okay, so I now have one angle congruency. Do I have a second one in there? Well, I've actually got a couple of them, but if I'm gonna try to do this one. Why are those two angles going to be congruent to each other down here at F? And hopefully you remember those are congruent because they're vertical angles. So now what I'm going to do is I'm going to write a similarity statement. I'm going to very simply state one of the triangles. I'm going to call it FGH. Now triangle FGH I have shown has to be similar to another triangle. I need F to match with F in the other triangle. G has no mark on it, so it's going to have to match with U. And H is going to have to match with T. Now, I know that these two triangles are similar to each other, and my reason is angle-angle similarity. All right, let's take a look at this next one. On this next one, I know nothing about angles. I don't see any parallel lines to be able to do similar to what we did last problem. All that I see here are side measurements. So in my head, I'm thinking these triangles are similar by side-side-side similarity. But now I have to check it. I'm going to start to create that extended proportion of the sides. I'm going to start with 27. Now 27 in the first triangle has to match with 63 in the second triangle. Why? The two of them are the smallest sides. The next largest side in each triangle would be 30 and 70. And then finally, the largest side in both triangles would be 39, 39 and 91. Now, from here, I have a couple of different options. Option number one is I can simplify each of the fractions. Okay? If I simplify each of the fractions, they should all simplify to be exactly the same thing. Option number two would be to cross multiply, doing kind of two ratios at a time. So in other words, the proportions that we're used to. I'm going to choose to simplify each of these fractions. I know 27 and 63, 9 go into both of them. So this simplifies to 3 over 7. I know 30 over 70, 10 goes into both of them. So that gives me 3 over 7. Hey, we're looking good right now. If this third one can simplify to 3/7, then we have proportionality occurring. So let's see. I'm going to go and grab my calculator just to help me with the calculations here. So let me do a quick search here, grab my calculator. 39 and 91. Now, I need somehow to figure out what goes into both 39 and 91. I'm going to try 39 divided by 13. Well, that gives me 3. So if 91 divided by 13 gives me 7, I'm good to go. Let's try it. 91 divided by 13, 7. Good. So what I have done here is I have now verified that these ratios we created are proportional. I can now make a similarity statement. I'm going to call the first triangle ABC. ABC will be similar. Let's see. AB includes that 30, right? And 30 was the middle. And I went from smallest side to largest side. So I'm going to look over here. Which one of my measurements goes from smallest to largest? Smallest to largest and includes the middle side. That would be TS. So I'm going to say triangle T matches with A. S has to match with B. And C has to match with R. I know these two triangles are similar by side, side, side similarity, and I have verified that. Let's try this third one here. Now, in this third one, I do see an angle congruency. All right? So immediately, I'm going to write down, I know that angle U is congruent to angle J. Now, are the sides proportional? I don't know. I'm going to check. I'm going to go 66 over its corresponding side, 77, equals 66 over 77. Well, this one's pretty easy because if you look at them, the fractions are definitely going to be the same. All right, so we have a proportionality of sides that include the congruent angles. I can conclude the triangle VUW is similar to triangle, let's see here, how about KJL? And remember, naming these in the right order is absolutely critical. The reason why these two are similar is because of the thing called side angle side similarity. Let's try one more here. All right, I'm thinking side, side, side. Okay, I'm going to start with the smallest. I have 12 over 39. That has to equal the second largest is 25 and 78. And the largest is 27 and 91. Okay, so if I look to simplify these fractions, they must all simplify to give me the exact same fraction. Now, for me, there's one that jumped out at me. I recognized right away that 27 and 91 would simplify to 1/3. All right? If you don't believe me, here's how I knew it. 91 divided by 27. Oh, it didn't work. What am I thinking? Oh, you know what? I was 81. Whoop, dummy me. All right, so I'm going to erase this now. All right. Let's see, what goes into both 12 and 39? Oh, man. 12 and 39, let's see, 3 goes in, so that gives me 4 over 13. Okay? And all of a sudden, I'm just not feeling real confident with my simplifications and stuff. So here's another way that I could do this, only because I'm reaching this question mark. I'm going to start to look at these proportions and check the cross product. So in other words, if I just check these first two, all right, I know that the extremes would be 12 times 78 or 936. And the means would be 39 times 25, which is 975. I can stop right now because I know that this cross product that I just checked does not work. No, it doesn't work. Therefore, I can conclude these are not similar. Okay? Which means I'm not going to be able to complete that statement that they want me to complete. All right. The second task for today is how do I find missing sides? And notice what they do here is they tell me that the figures that you're dealing with are in fact similar figures. Okay? Now what this similarity statement does right here is it allows me to create the extended proportion. So on this first one, I'm going to write it all out so you see it. I have BC over BR. Notice how I match the first two letters in each of the triangles, one on top, one on the bottom, to represent that side measurement. I know that that has to equal CD over RS. And I know that has to equal BD over BS. This is what it means whenever we hear the word similar. That we are able to write this extended proportion in order to help us find missing pieces. Now, if I use this as a guide, the way that I like to do these problems is I always start with the question mark or what side they're trying to get me to find. They want me to find DB, so I'm going to say X over DB. Let's see. DB is the same as BD, so I have to match that with BS. I know that BS is 9. That has to equal. Now I have to go back to that triangle where X was. The other side is 21. 21 is BC. BC has to match with BR, which they tell me is 7. I've now created a proportion that I can solve. So I have 7x is equal to 9 times 21. Let's just do the arithmetic on the calculator. 189. Solve for x, divide by 7. And I get x is equal to 27. So the hard part on similar figures and finding missing side in similar figures, the hard part is the setup. We've now for like 4 lessons in a row been solving proportions. But the hard part is, can you set it up properly? So let's try another one right here. Some people have a hard time seeing two triangles here. So let me kind of outline the two triangles for you first. Here's one of the triangles, and most of the time guys don't have any trouble seeing that. And then with a highlighter, I'll do the second triangle. All right. Now, I oftentimes call this big triangle, little triangle, just to help myself. I notice that the question mark, the piece that I don't know, is the piece of a little triangle. Okay, so I'm going to say X over. Now, I need the corresponding piece of the bigger triangle. That's going to be this whole side here, which is represented by 28. So I have X over 28 equals, I need to go back to the little triangle, find another side. There I'm going to use either 36 or 48. I'm going to choose to use 36. It doesn't matter though. If I use 36, the corresponding piece of the bigger triangle is this 42. So I'm going to write it like that. Now, I can simplify, or I can just dive right in and use my calculator. I'm going to choose to do that. 42x is equal to, let's see, 28 times 36 gives me 1,008. I take 1,008 divided by 42, and I get x is 24. So that missing piece right there, EJ, of that small triangle is 24, which also means that this piece JG down the bottom would be 4. Why? Because the two pieces have to add up to 28. All right, so let's take a look at this one. They give us a similarity statement right here. That's always nice when they give you that. I don't remember seeing that in the second one. There wasn't. All right. They tell us that these two are similar. All right. So I see x in this expression 2x plus 17. I'm going to write down what I'm trying to find, 2x plus 17. This side is NM. I know that according to the similarity statement, NM has to match with BC. BC is 27. I go back to the first triangle, 30. I've got that as another piece. I know that 30 is LN or NL, depending on how you want to look at it. And that's got to match with BD. BD, they give me is 18 here. Now, a little bit more complicated equation to solve, but we've done these before. All right? Remember to parenthesize. Why? Because it's a binomial. So I've got 18 times 2x plus 17 equals, and I'm just going to write it out like this, 27 times 30. All right. So this would be 36x plus, let's double check, 18 times 17 is 306. And then 27 times 30 is 810. All right. I'm going to subtract 306. So I have 36x is equal to 810 minus 306, which would be 504. Divide 504 by 36. Divided by 36. And I get x is 14. All right. Let's take a look at one last problem here. Hopefully these have helped you. I would encourage you to keep these open and kind of refer back to them when you're doing the homework number 7-4. All right. So let's take a look here. I see a big triangle, little triangle scenario. I see 13x is one of the measurements of the sides of the bigger triangle. So I'm going to say, all right, 13x is what I want to start with. I always like to start with my variable first. I know that the big side over here has to match with the small side in the smaller triangle. So I'm going to match that up with 45. Now, I can either go 169 over 65, big over little, or I can take 182 over 70, big over little again. This time I'm going to choose to take 182 over 70. Now, because these are similar figures, it doesn't matter which pair I use. I just have to do the side measurements in the same order. Big triangle over little triangle in this case. All right, so if I take 13 times 70, I get 910x. And that's equal to 45 times 182, which is 8,190. Divide that by 910, and that tells me that x is equal to 9. Hope this helps. Good luck. Please complete the homework 7-4 that goes along with the lesson.